What's going on, guys? This is part 2 of the scraping slash navigating Gamefaqs video series. Before we get started with locating the upcoming PlayStation Vita game releases, I want to go over some soup methods that we haven't covered yet, and we're going to need to utilize these methods in extracting the upcoming video game releases. So let's just talk about some of these methods that we're going to need to utilize. The first one is find and find all. So I don't need to cover find and find all much because we've already used this. Find parents is something we've used in the first video, and find parents finds all the parent tags of the string we're trying to locate. I will give specific examples on each of these so you guys don't have to worry. First, we're just going to start off with a brief overview. Alright. Find next siblings and previous siblings is something I'm going to show you as well. And then we have find all next and find next and find previous. Let's see, 1, 2, 3, 4, 5, 6. So there's 6 different methods we're going to look at, and 4 of them are new. Okay, so I actually have a sample HTML, and I'll explain to you what siblings and parents and children and all these things are. Alright. So this is the sample HTML. It's very simple. It just has 2 different divs. Here we go. These 2 divs are located within the HTML. So it's a pretty simple HTML. And I can actually run the HTML content to a certain degree from the Jupyter Notebook. So let's just run this. And as you can see, it has a header, New York. And New York is the home of various cultures and ethnicities. And then we have London, same thing. London is the home of various cultures and ethnicities. So these are the 2 divs. This is the one div and this is the other div. So it's a very simple page. And let me just go back to the code portion. Okay. All right, so let's just talk about what parents are and what brothers and siblings are. So it's pretty much a tree-like structure, a hierarchical structure. And HTML is the top. It's the first parent, or the top parent. And then as you go down through the tree-like structure, so like the div is one step lower. The div is located within the HTML. So the div tag is actually part of the HTML tag. So the parent of div is an HTML. A child of an HTML is the div. So in a sense, HTML is one rank higher, or one indentation. In this case, you can't really see the indentation because I haven't structured it properly, but it should look something like this. So the div is actually one step within the HTML. So the div is the son, or not the son, the child of an HTML, and the parent of div is this HTML. Don't concern yourself too much with the head and title. I think the head could be the child of HTML, but we're not going to concern ourselves with this portion. We're just going to deal with this portion and the HTML. So once again, I'm going to reiterate what I just said, summarize. The div is a child of the HTML, and the HTML is the parent of a div. Okay, so let me just fix up this indentation once more so we can see the tree-like structure, or the hierarchical structure of the HTML content. So the div also has children. So these 2 are part of the div. This header and this P. The P stands for paragraph. So a div has children. So div is the parent of these 2, and these 2 are the children of div. So hopefully that gives you an idea of what how children and parents work. The next thing I want to talk about is siblings. All right. So in this case, these 2 divs are pretty much the same rank, or the same depth level in this tree-like structure. They're both part of HTML, but there's no parent or children relationship between these 2. These 2 divs are at the same level, at the same depth level. This is what's called siblings. So this div and this div are siblings because they're at the same depth level. And these both divs are the children of the HTML. And HTML has these 2 div as its children. All right. So that's just the brief overview of what some of these siblings and parents and that sort of stuff is. Let's just start playing around with these methods and see exactly what we can pull out. So what we're going to do is we're going to test out some of these methods on this sample HTML code. Okay, I've actually saved this HTML code as a variable, HTML1. And the way you save HTML code is you can just use a multi-string and save it as a string. So let me just actually run this. Okay, so now I've already imported BeautifulSoup when we were scraping Gamefaqs earlier on, so I don't need to re-import it. And what I'm going to do is just run soup, and the string variable HTML1 is going to be our HTML content, and we'll use the HTML parser. So let's just run this, and it looks good. All right. So the first method, remember, we're going to go briefly through all these methods. The first two is something we've done numerous times, so I'm not going to go too much into the first couple of methods. But of course, you guys know soup.findAll, and it's going to find all instances of div in our code, our HTML content. So in our case, we had two instances of div here and div here. I'm sorry, div here and div here. So it's not going to concern itself with parents and siblings and children and all of that. It just finds indiscriminately all the instances of div. All right, so let's just clear that out. Okay, now let's go over a little bit of the find parents. So find parents usually finds the tags that are above itself. So in this case, since we're looking for a string, since we're using find string, what it's going to do is it's going to find the tag that it's directly located in, and then it's going to find the rest of the tags which are above that in terms of the tree-like structure. So let's just go back to New York. So the parents for New York, so there's two actually instances of New York, but find a New York, since we're using find New York, it's going to find the first instance. So the first instance is actually here, and the direct parent is going to be this, because we're actually looking for a string. We're now looking for a tag. So the first thing a find parent does, it's going to find the tag that it's located within. So find parent will find this, but remember, anything above in the tree-like structure is also considered a parent. So if we do find parents, this is a parent, and HTML is a parent. So let's just test this out. So find parent. So remember, we're only finding the first instance of New York, and if we run this, all right, so H2. So let's just go back, and H2 is the first tag that New York is located within. So we find New York string, and the first tag is the parent, the first parent. All right, so let's just run find parents now. So it should find many different instances, and let's look at the outcome that we get. All right, so we get a list-like structure, and it seems like we've gotten a lot of items. So the first item that we get is the H2, the header, which is what we got here. So find parents actually finds the first parent, which is the H2. Now, if you look at the second item in the list, remember these commas separate each item. This is the first item. This is the second item until we find the comma. So the comma is here. So this is the second item. So the second item pulls out what seems to be the div. So it pulled out the H2, which is one of the parents. Then it goes one layer higher, and it pulls out what seems to be the div, which is another parent. And now the third case seems to be pulling out all the HTML as well. So the third case is pulling out the HTML, which of course holds the div, which holds the New York. So the third case is pulling out pretty much our entire code. And then we have another element in this list, the fourth entry, and it seems to be the same thing as the first entry, but there seems to be some space here. So it's also pulling out some space. I'm not really sure what the deal is, but it's okay. We've gotten the parents that we wanted. All right, so let's just move on from this. Let me just clear this so we have some more workspace. And now we're going to check out siblings. Okay, siblings is a little tricky when you're working with strings. Okay, so here we have a string, New York. So the problem here is that we don't actually have a parent. We're not located within any tags. So this is going to result in an empty string. And the reason is that because to have siblings, you need to have some sort of tag encapsulating you. And we don't have that in this case. Okay, so even if we try, this was find next siblings, even if we try find previous siblings, we're going to get a similar output. So let me just run this and we get an empty string. All right, a workaround around this is, what we can do is first find a parent, which is going to give it some tags, and then we can find siblings for those tags. So remember, find parent, we had ran this cell earlier, and it pulls out the header tag. So once we get the header tag, the h2 tag, we can find the siblings. So remember, siblings are anything that's on the same level in the tree-like structure. So if we look at this div, and we look at the h2 is located within the div, but it's on the same level as this p. So these two, the h2 and the p, should be siblings. All right, so let's just go back. So the find parent is going to pull the h2, and then if we find the next sibling, we should be pulling out the p. Remember, we're finding the next sibling. All right, so let's just run this. And as we just talked about, we're pulling out the p, which is paragraph. All right. Now, if we try to find the previous sibling, remember, next sibling is just the next in terms of order, but h2 doesn't have a previous sibling. It has a next sibling, as you can see here, it comes afterwards, but there's nothing before h2 in terms of siblings. So, trying to find the next sibling should give us, trying to find the previous siblings should give us an empty string. So let me just run this. And as you can see, we get an empty string. Even if I try to run previous sibling, which of course will make no difference, we should get an empty string. Or in this case, it's a none. This is returning no value. No return means none value. All right. So what we can do is actually, we can actually call this sibling. This sibling has a previous sibling. If we go back, see, this sibling has a previous sibling, New York, and New York has a next sibling, P. So what we want to do is we want to pull out the P, and then we can call the previous sibling. So earlier we had pulled out the P. Okay, so this code, find parent and find next sibling, pulls out this code. So we can reuse this. So I can just copy this, which I did here. So this code is just a copy of, this whole thing is just copying this code above here, from here. And then we just, we can add on find previous siblings, and it should find the h2 New York. So let's just, where'd it go? Here we go. So let's just run this, and boom, we get the expected result of h2 header to New York. All right, now I'm going to go over a couple of other methods. The remaining two methods, which is find all next and find previous. So what find all next is going to do is going to find all the tags and elements that are coming after the tag that we are using as a parameter. So all the tags that come after the string or after the specific tag that we're including in the parameters. Alright, so these methods are very important, and we're going to start off with the find next. So the find next, like we just said, is just going to find the next element or tag. So in our case, if we find the string, so the string is here, so the next element that's popping up is this P. This h2 doesn't count because it's the tag actually started back here. So the element that we're going to pull out is the next element, which should be this P. It comes after the string New York. And always remember, even though there's two cases of the string New York here, we're only using find, soup.find. So soup.find only finds the first element. So this whole video we're dealing with just the first element of New York, or first element of London. Because we're not using find all, we're just using find. So find finds the first element of a said string. Okay, so going back to topic, we are going to pull out the next tag or element, which should be P. So let me just run this one more time. Let me just run this, and we should get the expected result. And it is indeed the expected result. We expected the P, and that's what we got. Now, what's the next element after P? So I wanted to show that by using find next twice consecutively. So using find next twice consecutively, what's going to happen is we're going to try to find the next element to this P. So let's just go back up. And the next element should be this London div. Even though it seems like this is the next element, remember, this means it's closing. We have this little backslash here, / means it's the end of an element. So the start of the element was actually up here. And when we use the next, we're actually looking for the next starting element. So the next starting element after P is going to be this div. And this div actually holds all of this information. So let's just run it. Okay, so find next should pull out the London div. So let's just run this, and it's exactly what we expected, the London div. All right. Now I'm going to use this find all next. So previously we were just using find next. Now we're going to focus on find all next. So let's look at all the tags and elements that come after this H2 New York. So we have this P, we have this div, and then it may seem like the H2 and P are not actually next because they're included in the div, but in reality H2 and P are actually their own elements and tags. So even though the div includes all of these, the H2 and P are their own tags and elements. So we should be pulling out this P, this div, which includes everything, and then this H2, and then this P. So we should be pulling out 4 different elements. So let me just run this and see what happens. Alright, so this is the cell, find all next. Let's just run it. Okay, so we get a list of all the entries. Remember, the commas are separating each entry. So we get the P, then we have the div, which we expected, and then the London, and then the P. The London and P are part of the div, but in this case, they're also separate entries, so we got them as separate elements and tags. Alright, so this time we'll use London as a string and find all next. I just wanted to change things around a little bit. So, alright, so London doesn't really have much coming after it. So the only thing remaining is this P, and then the code, the HTML code comes to an end. So the only thing I'm expecting is this P. So let's just run this. Here we go, find all next. And if we run this, it's exactly how we expected. It's just the P. All right. So now we went over find next and find all next. The next thing I want to go over is find previous and find all previous. So this is actually the last method within the 6 methods that we wanted to go over. Find previous is the same thing as find next. The only difference is we're going in the opposite direction. So find previous is going to find the first instance of a tag or element that comes before the string. So soup.find is going to find the first instance of a string, and then find previous is going to find the first instance of a tag before that string. So if we look at the string, New York, right? So New York is a string. The first instance of a starting tag or element is this H2. Remember, the H2 is starting here. So let's just check out the result of find previous. And as expected, we get the H2, because remember, the H2 is starting. We're always looking for if something is starting before or after. The find next or find all next, and the find previous and find all previous are always looking for something before or after, but they're always looking for something that's starting either before or after. So this H2 is starting before find previous. It's the closest previous entry to New York, so that's why it's the first entry we pull. Now find all previous is going to pull out a bunch of things. So let's look at what find all previous is going to do. So if we have the New York here, there's 1 entry before it that's starting. This div is also starting before it. That's 2 entries. Then we have the head here, which is also starting before it. But before the head, we have the title starting before it. Then we have the head starting before it. And then we have the HTML. So all of these are supposed to get pulled out. The H2, the div, the title, and then the head, the start of the head, and then the start of the HTML. So let's just run our code and see the results. And if I run this, as expected, we get a list. We get the H2, then we get the, which we expected, that was the first entry before. Then we get the div, holding the New York, which we also expected. And then we get the title as its own separate entry. And then the head, which also includes the title, and then the HTML, which is of course the entire code, because the HTML is the first parent, the super parent. Okay, so we went over, let me just go back to the top, we went over all 6 of these methods, And the reason why I wanted to go over these methods is because in the next portion, when we're trying to pull out these upcoming PlayStation Vita game releases, we need to utilize some of these methods. The first video, Find Parents, was more than enough to pull out the top 10 most popular games, but in this case, I had to rely on a couple of methods, and I figured I should make a video about this because some of these tools are very powerful. Alright, so that's it with this video. The next video will be actually trying to pull out the upcoming PlayStation Vita game releases. Yeah, so I'll see you guys in the next video. Alright.